Do you know who was Sir Isaac Newton? What he invented? Why he called as a natural philosopher? If not, okay, just give me 10 minutes from your expensive time so that I will tell you. And please, so don't skip and listen carefully. Sir Isaac Newton is a remarkable story of curiosity, intellect, and the pursuit of scientific knowledge. He is widely regarded as one of the most influential scientists of all time. His work laid the foundations for much of modern science, particularly in the fields of physics, mathematics, and astronomy. Firstly, Isaac Newton was born on January 4, 1643, December 25, 1642, Old Style Calendar, in Woolsthorpe, Lincolnshire, England. He was born prematurely, and his survival as an infant was uncertain. His father, also named Isaac Newton, had died 3 months before his birth, and his mother, Hannah Ayscough, was left to raise him alone. When Newton was 3 years old, his mother remarried, and he was left in the care of his maternal grandmother, a situation that is believed to have caused deep emotional wounds in the young boy. Newton's early education took place at the King's School in Grantham, where he showed little interest in his studies. However, when his mother attempted to pull him out of school so that he could become a farmer, his headmaster recognized his potential and persuaded her to let him continue his education. Newton later attended the University of Cambridge's Trinity College in 1661. He entered as a subsizar, a student who works in exchange for financial support. At Cambridge, Newton initially studied the standard curriculum of the time, which was based on the works of Aristotle. However, he quickly became fascinated with the more modern scientific ideas of René Descartes, Galileo Galilei, and Johannes Kepler. During this time, he also began to explore mathematics, optics, and astronomy. He made significant progress in mathematics, particularly in the development of calculus, although his work on this subject would not be published for several decades. In 1665, the Great Plague of London forced Cambridge to close, and Newton returned to his family's farm in Woolsthorpe. This period, often referred to as Newton's Annus Mirabilis, or Year of Wonders, was incredibly productive. During the 18 months he spent away from Cambridge, Newton laid the groundwork for his future breakthroughs in mathematics, physics, and optics. He has discovered some major contributions like: Number 1. Mathematics, the development of calculus. During his time at Woolsthorpe, Newton developed a form of mathematics that he called the method of fluxions, which we now know as calculus. This was one of his most significant contributions to mathematics. Though Gottfried Wilhelm Leibniz independently developed calculus around the same time, a bitter dispute over priority later erupted between the two men, with supporters on both sides. Newton's calculus allowed him to solve problems involving rates of change and the summation of infinite series. These ideas were revolutionary and crucial to his later work in physics. Number 2. Optics, the nature of light and color. Newton returned to Cambridge in 1667, and in 1668 he built the first practical reflecting telescope, which used mirrors instead of lenses to avoid chromatic aberration. His interest in optics led to a series of experiments with light, which culminated in his discovery that white light is composed of a spectrum of colors. By passing light through a prism, Newton showed that it could be split into its constituent colors: red, orange, yellow, green, blue, indigo, and violet, and then recombined into white light. This work challenged the prevailing theories of light and vision, and in 1672, Newton published his first major scientific work, Optics. Number 3. Physics, laws of motion and universal gravitation. Newton's most famous work, Philosophiae Naturalis Principia Mathematica, commonly known as the Principia, was published in 1687. In it, Newton formulated his 3 laws of motion. First law, inertia: an object will remain at rest or move in a straight line at constant speed unless acted upon by a force. Second law, force and acceleration: the force acting on an object is equal to the mass of the object times its acceleration, F equals ma. Third law, action and reaction: for every action, there is an equal and opposite reaction. In addition to these laws, Newton also described the law of universal gravitation, which states that every mass exerts an attractive force on every other mass. The strength of this force is proportional to the product of their masses and inversely proportional to the square of the distance between them. Newton's law of gravitation explained the motions of the planets and celestial bodies, as well as everyday phenomena such as falling objects. The Principia is regarded as one of the most important scientific works ever written. It not only provided a unified description of motion and gravitation but also laid the foundation for classical mechanics, which would dominate scientific thought for the next 2 centuries. After that, in the late 1680, Newton began to take on more public roles. In 1696, he was appointed Warden of the Royal Mint, and in 1699, he became Master of the Mint, a position he held until his death. In this role, Newton was responsible for overseeing the currency and leading the effort to reform England's coinage, which had been plagued by counterfeiting. He took his responsibilities seriously, going so far as to personally investigate counterfeiters and bring them to justice. During his time at the Mint, Newton also became a member of Parliament and served as President of the Royal Society from 1703 until his death. He was knighted by Queen Anne in 1705, becoming Sir Isaac Newton. Despite his genius, Newton was known for his prickly personality and his contentious relationships with other scientists. One of the most famous disputes of his life was with the German mathematician Leibniz over the invention of calculus. While Newton had developed the method of fluxions during his time at Woolsthorpe, Leibniz published his work on calculus first, leading to accusations of plagiarism on both sides. This dispute became a bitter, lifelong rivalry between their respective followers. Newton also clashed with the physicist Robert Hooke, who had proposed an early theory of gravitation. Hooke's work, however, was not mathematically rigorous, and Newton's theory ultimately superseded it. Nonetheless, Hooke's criticisms of Newton's early work in optics led to a tense relationship between the two men. Newton was deeply interested in theology and alchemy, although these aspects of his life were not widely known during his lifetime. He was a devout Christian, but his religious views were unorthodox. He rejected the doctrine of the Trinity, which put him at odds with the established church. Newton's theological writings, which were not published until long after his death, reveal his belief in a form of Christianity that emphasized personal piety and a direct relationship with God. Newton also spent considerable time studying alchemy, the medieval precursor to modern chemistry. He believed that alchemical principles could help unlock the secrets of the universe, although his alchemical pursuits did not lead to any significant scientific breakthroughs. After all, Isaac Newton died on March 31, 1727, March 20, 1726, Old-style calendar, at the age of 84. He was buried in Westminster Abbey, an honor usually reserved for royalty and distinguished figures in British society. Newton never married and had no children, and his estate passed to his nieces and nephews. Newton's legacy is immeasurable. His work in mathematics, physics, and astronomy laid the foundations for the scientific revolution and transformed our understanding of the natural world. His laws of motion and universal gravitation provided the basis for classical mechanics, and his work on optics and light helped pave the way for modern physics. In the centuries since his death, Newton's influence has only grown. Albert Einstein, who developed the theory of general relativity, is often considered Newton's intellectual successor, but even Einstein acknowledged that his work stood on the shoulders of Newton. Today, Newton is remembered as one of the greatest scientific minds in history, a true pioneer who unlocked many of the fundamental principles governing the universe. After all, we all like to thank him for his dedication and contribution, which makes to understand and helped us to make our work easy and fast.